Good morning, everybody, and welcome to Continuent's Wednesday webinar. My name is MC Brown. I'm the VP of Products here at Continuent, and I'm going to be taking you through today's topic. We're going to be having a look at Tungsten Replicator for Kafka, and we're going to have a look at how we can replicate data from Oracle and MySQL into Apache Kafka. Before I get started and start having a look at the details of this, just a few little admin items. So this session is being recorded. If you want to come in and view it again, you want to come and pay attention, maybe review some of the notes, it will be posted onto our website as soon as this webinar has been finished today. You can also answer questions. If you go over and have a look at the questions section on your panel over here, you'll be able to answer questions on the service. I will do my best to answer questions as we go along, and there'll probably be some time for it at the end. I also have some associates from Continuent on here with me who will be able to answer the questions if they can while we're going through the service. So with that out of the way, let's get started, and let's start having a look at what we can do with Tungsten Replicator and Kafka. So we actually went ahead and added the new Kafka applier in our new 5.2.0 version that came out in July, just last month now. And you know, there are a number of reasons for why we wanted to add Kafka. One of the clear ones is obviously lots of people want this. Lots of people want to be able to move that data into Kafka. But what I want to talk to you today about is why you would actually want to do that and how we can help you do that using the replicator. And we're going to talk about why you would use Kafka, you know, how the replication works, what it does, and then when you've got the stuff into Kafka, what's the potential for you to be able to do stuff. I'm not going to dwell too much on that because obviously that's outside of what the replicator does, but I am going to have a look at the kind of things that people are doing with Kafka and those kind of technologies, and then we'll also have a look at a couple of future directions that are kind of related to the Kafka system and the Kafka support that we have built into the replicator. There's also going to be a demo. We'll have a quick look at what replication actually looks like. We'll be able to go in and see what happens when we do it. We'll also be able to go in and see what happens when we kind of have a really busy system. I'm hopefully going to try and simulate writing a huge number of records into our source data system. And when I do mean a huge number of records, I really do mean a huge number of simultaneous records into the system and out into Kafka. And you'll see what the performance is like. And obviously, with our first version, we're aware there are going to be some kinks that we need to look at, but we can have a look at that as we go through. So, first of all, why would you happen to be looking at Kafka? Well, you know, let's start off with what Kafka is, right? Kafka is basically a high-performance message bus. There are lots and lots of different message queue systems out there, and message queue systems have been around for a long time. Obviously, there are similar ones like RabbitMQ, and many others. I'm not going to sit here and list them all off, but the whole basis of a message bus is that you want to be able to send out a relatively small, discrete little message onto a system that enables you to view it and monitor it. The Kafka system works on the same on many others. You have a number of individual topics. Within those individual topics, you can obviously publish a message on a particular topic, and then obviously you can pull that message off if you're monitoring for that topic through a series of so-called subscriptions. And this is a solution that is used in a whole variety of different techniques. One of the main things about Kafka is that Kafka is highly and heavily distributed. Right, so your typical Kafka system is going to be made up of a number of different nodes, and you're going to have the ability that when you write your data out into Kafka, you obviously want to be able to write that data out and say, I want to guarantee that this message is going to be at least recorded and enabled by the system before we were able to distribute it on to the subscribers that are going to be able to take it. Now, it's important to remember that at the bottom line, Kafka is not a database system. It is literally a list of messages that you can publish and subscribe to. You know, think about it as a email, but a bit more practical because we can kind of send anything we like over that format in a relatively discrete and high performance fashion. And it's great for those kind of situations where, you know, say you've got an application, you want to be able to take that data in from maybe multiple sources and you're pushing it over the message bus. Maybe you want to take in that data and you want to take in the data and aggregate a load of information from logs. So if you've got your logging system, you've got your web logs, you've got monitoring systems that are putting in that data, you can use Kafka, publish all of the information out onto a Kafka message queue, subscribe to it, and take that information and be able to take that information in and then write it down and store it somewhere else. It's also great for those situations where you want to be able to say, fire off a particular item. So, you know, good example here, if you have a website and the website enables people to upload an image, but when you get the image, you want to be able to create a thumbnail of that information, of that image, so that you can then include it, and you might want to create a thumbnail of different sizes. But there are a variety of ways in which you could do that, but an easy way to do it would be to have a series of machines sit there waiting for an indication that a new image has been uploaded, and then they sit there and process it. That takes the system outside of your database, outside of your application, and enables those things to happen, you know, in the background alongside your main operations. So someone uploads the image into the database, you say you've got it, it appears, and then over time in the background, the thumbnails are created and the thing becomes available. And again, you know, we've all been familiar with these kind of processes where that kind of system works. You know, if you've ever uploaded an image, you know, up to something like Flickr, or maybe you uploaded a video up to something like Facebook, they have these systems that go away and kind of do a load of processing in the background and return back. Now, also, because of the way that the Kafka operates and the way that it integrates with other systems, it is very, very simple to then use that and combine it with other systems. So, for example, it's very frequently used with Hadoop because we can have a number of Kafka subscribers listening for messages. So if you are doing that log aggregation, you are doing security tracking, whatever, you can ingest all of that data into Hadoop very, very quickly and simply. So, you know, that leads us to a number of different scenarios. Here I'm just using Hadoop. You know, imagine that you've got a bunch of databases. They're all generating a lot of information. Maybe they're sales, you know, maybe they're you know, blog posts, maybe they're images, that kind of information. We take all of that information in. We can take all of that information out of your database. So we can extract that data out of your database, out of MySQL and Oracle. We can push it out to Kafka, and then Kafka can be responsible for passing that information and passing it on to Hadoop. Now, this is one, you know, possible model. Obviously, this is the log aggregation style model of being able to take all of this information in. There are other models. I mean, I mentioned another one, multiple target distribution. Obviously, you take the information in, you push it out to Kafka, and you have something that is maybe doing image processing, another one that emails that, you know, emails that request onto somebody else, another one that stores it and takes it away into metrics. And we could be doing this for multiple databases. We could be doing this for multiple sources. We could be processing all of this information, passing it through Kafka as the underlying system, and then passing it on to whatever downstream processing or other system is on the other end. The point here is that we can take all of this data in, push it over Kafka, and the replicator can pump that data through as quickly as possible directly from your database. So instead of taking the information and taking it out of you know, your application and your application process, we can trigger the entire thing off of the back of committing an individual transaction into your database. And this obviously means that it's much more integrated into your system and provides a level of reliability that maybe you wouldn't necessarily be able to get. Very easy from an application layer, for example, to say, well, I've written something into the database. Oh, whoops, I couldn't write to Kafka, and suddenly that's not handled anymore. If you trigger off of the database, then you know the two things are correct and in sync, because we don't take anything out of the database from a replicator perspective that isn't a transaction, and we don't write anything out to Kafka that isn't something we've extracted in full. So you can see that this offers a better level of maybe of communication and distribution of information than you would get out of a typical application-driven process with Kafka. Now, how does that actually work in principle? So you may have seen this diagram before, and obviously we've covered this in previous webinars, but it's worth repeating. We extract the data directly out of MySQL or Oracle. In this case, this is actually our Oracle extractor. We pull in the information out. We always pull out an entire transaction, right? We pull out that entire transaction. We put it into our own system, which is called THL, which is the transaction history log. We take that information. We have that THL. At this point, it is basically row-based data. That is, you know, we know the contents of each of the columns, each of the fields within the row of data, and we know that there are one or more rows in that information. Obviously, if you've got a transaction and it's a single row, we've got that. If it's a transaction and it's 10,000 rows, we've got that too. We pull all of that information out, we put it into our THL, and then we apply it out into Kafka. And the way that we apply that information out into Kafka is we actually take the incoming row and convert each individual incoming row into a Kafka message. So Kafka messages are structured so that the content of a Kafka message is basically each message has its own message ID, and the message also obviously has the payload, that is the message content, and then you have the topic, which is your way of compartmentalizing the data into the different streams within Kafka. We take that information, we should convert it into a message. We actually convert it into a JSON document. We take that information, convert the message into a JSON document. We embed a series of metadata into that information. So we embed the schema name, the table name, sequence number, timestamp, etc., other information, so that you can actually see where the data came from. So it's a completely and utterly encapsulated message. We then embed the message content. So this is obviously a JSON representation of the original source row. So key value pairs of obviously column name and column value. And obviously this is the replicator, so we can perform a number of translations and transformations on that. If you have a binary value and you want to convert it into bin hex, etc., we can do that for you, because that's a standard feature of the replicator to be able to take that information. And then we convert it into a message, one row for each message as the information goes out. So let's have a look at that and see what that looks like. So you can see here, one individual row gets converted into an individual message. You get to choose, how this information is represented. You get to choose what the data looks like. So you can choose whether we embed these different pieces of metadata. You can choose whether how we construct the message ID, and how we make this system look from a Kafka perspective. But the important thing to remember here is we're replicating changes from the database. So we also embed the operation type. So if you do an insert on your database, what you're going to get is you're going to get a load of messages out into Kafka that say, this is an insert into your database and passes the data through. If it's an update to the table, we will mark it as an update and show you the new version of the record as the data goes through. We are also going to take that information and do a delete and take that same information and obviously again mark it as a delete as it goes through the process. Now that might seem like a relatively obvious and yet trivial item to describe, but the important thing here is that information now provides you with a change log. If you wanted to take this information and maybe ingest it into Hadoop and you wanted to use it for auditing purposes, you wanted to track a list of all of these changes, or even when you were doing some of those examples that I gave earlier, right, where we are taking the information, we are taking that information out of the system, and you want to be able to process it. Someone has inserted a record, maybe it's a new image, you want to make sure that you process the image, update the image. Obviously you want to delete the old version of your image in the system, and take that data out. Obviously, if you want to delete it, you want to remove that information from the target system. There becomes a wide variety of uses that are available to you to be able to take this information out and use it for all of these purposes. Auditing, aggregation. Obviously within the replicator, again, we can perform a number of different operations within the replicator. We could actually take that information out. We could be taking information out of the replicator and reformatting it. We could take entire operations out. So if you wanted to say only record insertions, you can do that and handle that within the replicator. The replicator can obviously filter individual events from the transaction history log. So we could filter out all of the ones that are only inserts and handle only those inserts as they go into the system. Now also, remember the replicator is able to aggregate information from a number of different systems. And if you remember back to that earlier diagram, you can have one replicator that might be extracting data from multiple source databases at the same time, but ultimately concentrating it down and passing it out to one Kafka cluster. You can have multiple different versions of that. You could have one replicator reading from multiple databases, or multiple replicators reading from multiple databases, but ultimately writing into the same Kafka cluster. You could also change and modify the data. We could be taking the information in and maybe appending the source database name to each row of information. We could be embedding that information into the JSON as it gets written into into Kafka. All of these systems are flexible because we can chain each of the individual elements within the replicator to perform a combination of the filtering and other operations that we need. Now, obviously, the way in which this information is formatted at the moment, like I said, this is our first version, our first release of this particular option. We have a certain number of things that can obviously be customized as they come through. So we can actually control how you write data into Kafka. So it's possible to write data into Kafka and not worry about whether it's actually been accepted by the Kafka system. We can configure it so that we can guarantee that transactional state. So we can say we definitely have written this into Kafka cluster before we move on to the next row. You can also configure the distribution of the replication. So again, Kafka is a clustered system. You can actually say, I want at least one copy of this to have been written to one of the Kafka servers in the cluster. You can increase that and say, I want it to have hit all of them before I definitely say we move on. And again, this assists here with the transactional consistency. We can also change the format of the message key. So you can embed the table and schema name. You could just use the primary key information, which we extract from the database. You can use a combination of all three, and then obviously you can choose what metadata we include into the system. Maybe you don't care about the schema or the table name that it's come from. You're more interested in just getting the raw data as it comes across. All of these things can be configured. Obviously, you can also configure the topic name that it's written to. You know, the default is for us to use the schema and the table name as the topic name as it gets written out. You can obviously change that and reconfigure that. There's ways in which you can say, actually just write all messages to the same topic within the replicator. So the entire stream, we don't care what database, what schema or table it comes from. It writes out that data and we write out and store that information, and it just writes it out to that same topic. If you didn't want to do that, obviously, again, the replicator, we could use a variety of filters that would chop, change, configure, reformat the information, so we could rename the topic from the schema and the table name that gets written out. Again, all of these things are possible and are standard features of the replicator that we're able to just embed into the way that the replicator works when it's ultimately applying that data down over to Kafka. So just before we move on, I would like to show you a demo and kind of give you a quick overview of exactly what's going on under the scenes when we go ahead and do this. Before we do that, I do have a question here. Can Oracle Golden Gate do this as well? So yeah, the truth is that Golden Gate does actually have a Kafka applier. The Golden Gate Kafka applier obviously works with a variety of their different tools, and again is fairly configurable. You can choose how it's output. They output in a few different formats, and there are a few different configurations, and some of these things are obviously things that ultimately we will add and embed into our product as we produce and come up with new versions of this product as we go through. Certainly, if there's anything that you see that Golden Gate can do that we don't, you know, feel free to ask for it, and we'll see if we can get it added. You know, we're more than interested in being able to do that for you. Hopefully that's answered your question, Sam. If you've got any more, please feel free. So let's have a look. Let's see what this what our Kafka output. And obviously, you know, Kafka is not in its basic value something that looks like it's got a hugely interesting output in the system. But let's see what we can do to produce a simple system. So over here, I've got a MySQL server over here on the left, and I actually have our Kafka host over here on the right. So I'm just running a local version of Kafka on a single node, just for the purposes of this demo. You can see here we got I'm just showing the output from tripctl, showing the status so that we can see it's up to date. We can see it's up to date on the other side. And for the purposes of having a look at the performance, so I also have our new performance output that's also available in 5.2. You can see the performance of the replicator as it goes out. Now, what does it actually look like? Well, I've got a simple command line consumer. Again, this is part of the standard part of the standard Kafka toolkit. So we've got a very simple consumer here, which is going to take the information. You can see I've you know, inserted some information before. and you can see what the data comes out like on the other side. Obviously, it comes out as a JSON formatted image, and that's not a very message, rather. That's not a very friendly format. So let's see if we can convert that into something which is a bit more friendly. So you can see here, obviously, we've got the source schema and the source table information. This is part of the metadata. We've also got the sequence number, so we know exactly where it's come from in the THL. We know the operation type, and obviously we know the commit time, and then the actual record of the information is contained here. We could have done a variety of different transformations and formatting on this output as it went out, but in fact we just left it. All of these items are configurable. You can actually just have it so that all we output is this record information embedded into the main message. And if I go in and do an update, so if I do update test.message set message equals and I'm going to take the ID from here because that's what it's there for. Whoops. And I'm going to take the information. If I go over here and have a look, you can see that we've obviously got a very simple update. Let's do that again. So you can see again we've got the full update information, and you can also see you know that we've actually got a full version of the record. If I go in and delete it, you don't get the full version of the record, but again actually that is available. If you wanted the full list of columns that are included with delete, we can configure that within the system. Just a couple of notes, in fact, about the way this is configured. This is the same as most of our standard heterogeneous replicators. That is, it's configured to extract, obviously, the column name and primary key information from the source database, and we extract that information and insert that information into the THL. I think it's worth just having a look and seeing what that THL looks like, so that you can see that this is pure raw information that we ultimately apply through to the other side. You know, this is a MySQL source. The same is true for Oracle. We get almost exactly the same output as we do for Oracle. What we don't do at the moment, and what we haven't decided exactly how we're going to handle this, is obviously there's a huge amount of metadata that we extract both for Oracle and MySQL about how the data was extracted. We may or may not ultimately choose to include that in the output, the information that gets output into the Kafka message. I'll talk about how that might be significant in future releases of the replicator as we go through, but you can see what the information looks like. Now, meanwhile, let's go back to our Kafka server here. You can see here that we're up to date, and you can see here that, you know, the latency is relatively low here. You know, certainly sub-second. Obviously, we're only inserting a row at a time, so that's not maybe hugely surprising that we're able to go ahead and do that. What we can do, however, is we can try inserting a slightly larger body of information. Whoops. And we can go and have a look what it outlooks. So we've got this new performance output here in the new version, the 5.2.0 version of the replicator, and you can see that we've actually just inserted a huge number of a huge amount of information into the database. It all comes through as one transaction, and let's just have a look how big that transaction was. So there's 1,001 rows in that transaction. So we've just inserted 1,001 rows. Latency is about 2 seconds, which is not bad for a huge number. But you can see down here that the average amount of time we're spending actually just applying that data in is relatively small. If I do a much larger, now I should warn you that this is particularly massive. What we're actually going to do is I'm going to attempt to insert about 4 billion rows into a MySQL database, which itself takes some time. And you can see how we start processing and applying that information over into the Kafka side. You can see here, we're down here, we're applying individual events, which is about 1,000 rows a time, 1,001 rows a time. We're applying that information in a very small period of time. The numbers here, again, remember I'm running Kafka on my laptop in a single CPU VM, so you can see we're getting the information across. It says 3 seconds here. It does actually reduce quite a lot over time as we continue going through. I am inserting a huge number of rows over here on the other side. You can see that we're getting the data, and we're getting the data through quickly. At the moment, I should point out that as it stands, our Kafka applier is currently single-threaded, and we're not doing multi-threaded. So this is actually across 40 different tables, 40 different schemas at the same time. In the replicator, we have the ability to be able to do parallel apply, and we'll be able to apply that 40 times the same 40 different threads if we wanted to apply that data through, or indeed any number of threads that we wanted to configure. We will be adding that in a future version. The reason why we didn't add it in this original version is obviously to make sure that we've got the core product and the core functionality sorted out, and also because there are some issues around how we actually do that parallel apply. Generally, what we do is we split that across schema boundaries. So we would split it up. This schema gets applied by this thread. When you're applying into something like Kafka, obviously you don't need to worry so much about transactional boundaries because we don't have the same transactional semantics in Kafka. There are transactions supported within Kafka, but obviously it's something where in some situations you may actually just want to be able to switch that transactional boundary completely and utterly off. And that's something that we're looking at making sure that we add as we go through and process that information. So I'm going to leave this running because this is going to take some time. I'm actually going to stop this over on this side because otherwise it will sit there generating a huge amount. So you can see obviously the latency as comparity has shot up because obviously there is just so much data to be applied. You can see we're about 1,000 rows behind. If we go over here and have a look back at the TREP-CTL status, so another feature we added in 5.2.0 is we have this new counter here, which gives you a rough estimate of how long it's going to take before we catch up. You can see we're 930 transactions behind. Here it says 37 minutes. I suspect that will probably go down quite rapidly. But you can see how quickly we can get the data into Kafka, and obviously once we've enabled that parallel apply, we'll be able to go in, a lot quicker again. So let's go in and let's just see what other questions we've got here. So can Continuent relay data between SQL and Oracle and vice versa? Do you mean MySQL or SQL Server? I don't know what you're asking there. Yes, we can. We can do, we support extraction from MySQL and Oracle, and we can apply to any combination of MySQL, Oracle, Hadoop, Vertica, any of the different targets, Kafka, as I've just described. So Betsy, is it still written in Java? Yep, it's still written in Java, and the core of the replicator is still in open source. Although I should point out that the Kafka applier is not in part of the open source product. We tested, and that's something I would like you to get in touch with because I would want to know exactly what those are. I know we have spoken before. There are obviously issues depending on the size of your transaction and the overall size of the data that you're replicating. Does it still belong to VMware? No, we're no longer part of VMware. Haven't been for a year. Yes, you can buy support. There will be email addresses up at the end that we can sort out. Can we relay between different versions of Oracle? Yes, we can. So yeah, Oracle to MySQL. So that's the HP nonstop. Do you support the HP and HPE nonstop operating systems? Blimey, I have not heard of HPE for about 25 years. That was one of the first systems I ever monitored. No, is the simple answer. We don't support the HPE nonstop operating systems at this time. MySQL to DynamoDB. Please get in touch and we can talk about it. 10G R2 to 12C. Yes, we support any version of Oracle from 9i all the way up to 12C and any combinations thereof. Standard edition, enterprise edition, we'll do cross versions. We don't care. Any issues replicating data from MySQL to Redshift? No, not particularly. We are aware of an issue at the moment where if you don't have if you don't have security on your S3 buckets enabled, that there is an issue, but otherwise no, replication from MySQL to Redshift operates fine. So I think I've caught up with the questions. So let's just finish up with what we're talking here about Kafka. So what do we do? What else are we doing with Kafka? Well, the first thing is we are going to make sure that we get that full transaction support in for Kafka. The reason, again, that we haven't added it right now is because it does imply some overheads in terms of how we handle the replication of very, very large data sets. Obviously, you know, you can imagine you could do 100,000 rows. That obviously has an implication on the replicator and ultimately the Kafka server, because the Kafka server has to sit there and kind of queue all of those messages before ultimately committing the transaction. We need to do some testing before we work that out. Again, parallel apply, we are working on it. We do want to make sure that we get that working properly. I'm trying to change the way in which we do that so that we're not necessarily keying off of the schema. Then there's a bunch of other stuff that are going in terms of other features in the replicator. You know, obviously we want to be able to improve the replicator functionality in terms of the filtering. We want to add things like data obfuscation. Again, if you've read my blog, I have actually got an example of that. You know, improvements to the data modification. We already have a number of filters that will do that, but we're trying to add some standardized things like translating between different date formats and translating between different string representations. And also we want to be able to add, you know, some basic things like merging data from different sources. You know, some of the things that you may more traditionally do with an ETL tool, where maybe you're replacing a lookup value in a single column, again, is something that we'd like to be able to add. Then another thing that we're looking at, related obviously directly to the Kafka, is actually extraction out of Kafka, so that you could take data replicated into Kafka and then take it out of Kafka and maybe apply it into your database or apply it into one of our other targets. And again, this is something that that we are looking at and we are working on. It does require some kind of changes to the way the replicator works, and it also requires some changes in the way in which we will maybe pass that information and ultimately translate it into the THL that is required by the rest of the replicator. Because obviously we would want to make a decision about what is a field and what constitutes a field and a field boundary, because we may not necessarily be consuming information from the replicator. But this goes back to my earlier comment about the metadata that we extract. Maybe we would use Kafka in that situation and we'd extract metadata and put it into the message and then enable you to remove that information and reconstitute that THL over a Kafka message queue. And then obviously this kind of spreads out to a variety of different other topics that you could maybe get, you know, large-scale distribution of database changes. Maybe you want to take in information from, you know, lots of MySQL servers, push it out into Kafka and maybe feed off of that and distribute data to different individual database servers by having a look at different topics. And maybe you actually want to be able to take that information off of the Kafka queue and then resubmit it to a different Kafka queue and make use of the filtering that is available within the replicator. These are all of the kind of things that we're thinking about and trying to plan for the moment. So that's pretty much it. If you want to go in and have a look at the functionality and how it works and maybe try to use it, go in, have a look, read the documentation. I've actually also got a blog post about this up on my own blog, which is also on the Continuent website as well. You know, feel free to go and have a look at our other Tungsten University issues. We've got a bunch of different videos up there. We are always adding to those videos. We have replication, we have webinar Wednesdays rather, and we have training Tuesdays every other week, alternate weeks. Again, I can't remember what our topic is actually for our next training Tuesday, but the next one will be Tuesday next week, same time. If you actually want to talk to us about the Kafka reply or indeed any of the replicator functionality, get in touch and email us at sales@continuent.com. I'm just going to have a quick look at what other questions. We don't support SAP HANA. When outputting the record, can you perform additional queries, join data from other tables, or invoke custom functions? Well, hopefully I've just answered that. There is a limited amount that we can do based on the way that we extract information. The way we extract information is obviously we're extracting changes from the source database. So we're not doing a select on the source data and pulling it out. We're having a look at the change history that is built into the databases themselves. But there is a possibility that some basic merging of information is possible. If you want to talk to me and get an idea of the kind of things that we want to do, please get in touch with me direct. Let me just forward it on. My email address is up on screen right now. If you want to ask that question, William, you know, please email me direct, and let's see what the kind of things you're thinking about. Does it handle schema changes? So schema changes are irrelevant in a Kafka environment because there are no schemas within Kafka, but for the general replicator in the 5.3.0 version, which will come out at the end of September, we will have a new DDL translation tool, and we will support full DDL translation between all of our sources and targets. Is Tungsten Replicator open source? Yes, the core of the Tungsten Replicator is open source. It's on GitHub. Sybase or DB2? No, we don't support those platforms. No, the Kafka applier is currently not in the open source. We can extract from MySQL and Oracle, and we can put into Redshift. We did used to support Greenplum. Please go and have a look at our web pages for the list of all of the different targets that we currently support, which is currently expanding all the time. And yeah, DynamoDB, no, at the moment not supported. Postgres is coming in 5.3.0. MongoDB and Cassandra are supported right now. And I'm going to take that that is it for the moment, guys. We are a few minutes over time here. If you've got any more questions, please feel free to use one of the email addresses on screen right now. Contact us on the sales email address. Come and view the website. Come and get some more information. But for the moment, thank you very much all for attending. I hope you found this useful. I hope you've got a little bit more information about the replicator and what it's capable of and what it can do. Any other questions, get in touch. But with that, look forward to seeing some of you on our future webinars and our Training Tuesday next week. Thank you very much, everybody.